And now we have finished the storm drain shapefile review and development, and we will move on to storm drain setup. So let's go over this really quick. So calculate the conduit node connections. Wait, let's see. No, wrong. Select the storm drain components from shapefile, calculate the node connections, import the rating tables, schematize the storm drain, export the project, run the simulation, create a backup file. Okay, pretty simple stuff for storm drain because all the work is developing these shapefiles, not, building the storm drain system. That's relatively straightforward. So, step one, we will collapse the widgets and open the storm drain editor. Click the checkbox and click Set Components from Shapefile. And then you'll use these three images to set up your connections. So I'm going to open this in a new tab just so you can see it. And we'll be connecting all of these. And let's go ahead and start on that now. So they're already collapsed. That's good. Let's go to the storm drain editor. Check the Simulate Storm Drain button, and we need to select components from shapefile. And of course this needs to go to inlets and junctions. And now I just need to be really careful to make sure that these are all set correctly. Now you are not going to see this because this is your first time doing this, so you're not going to see this. So be sure to set this one to inlets and junctions. And this one, let's do this. That's the inlet name, inlet type, invert elevation, maximum depth, and these are probably not required, but you might want to set this one to surcharge depth for the manholes because I don't even see that I have a surcharge depth for my manholes, so maybe we'll set that to height. Or just leave it off. I don't know. Yeah, this is only manholes. I know that this one says surcharge, but really I think you need to be using this one, not this guy right here. And then this is the length or perimeter, width or area, height or sag, and weir coefficient, and the feature switch. And we're not going to we don't have curb height, clogging factor, or time for clogging, so we're not going to use those. And then the next one is outfalls. So that goes to outfalls. This one's a little bit easier. Name, invert elevation, flap gate, allow discharge, and type. I didn't really have, I know you saw me build a fixed stage for this, but I didn't actually have any data in there. I also don't have any title data in here. So I'm going to leave these three blank. Conduits, that is name, inlet node. Remember I said that these can be empty, they can be null, but the fields still need to exist. Outlet node, this is your offset for your inlet, the pipe offset for your inlet, the pipe offset for your outlet, the shape of the conduit, the number of barrels, the maximum depth, and this is that second geometry. So maximum depth is the first geometry, that would be the diameter or the height. And this is that second geometry, which would be the width or the, but basically the width. And then third and fourth geometries have to do with side slopes. Pipe length is the length of the conduit, number of barrels. No, sorry, that's wrong. Okay, let's make sure this is pipe length. This is not number of barrels. This is the roughness coefficient. And we don't have any initial flow, and I didn't assign any maximum flows in these, so I'm just going to leave those off. And I didn't use entry or exit or average coefficients, but you would probably want to assign those and set those up here. And then whether or not there's a flap gate goes here. So if you don't assign something, it gets automatically set to its default variable or just left off. So it's usually the default variable in EPA swim is 0 or left off. And we don't have any pumps, orifice, or weir in this system, so we'll just click Assign Selected Fields. And that is the end of that. What we have just done, let's go ahead and turn these three off. And what we've just done is we have converted that conduit system to the Flow2D conduit system. Let's go ahead and check back and make sure we didn't lose anything. So yep, we assign the nodes, and now we need to calculate the conduit node connections and import the rating tables for our type 4, or for our type 4s, and then we might get this error message, but I think we've kind of fixed that error message, so we may not get that anymore. And then we'll schematize the storm drain. So let's try that now. So we need to auto assign the conduits. We didn't have those other features, so we don't have to auto assign those. So what that did was that took these conduits and it used a buffer to identify the node at the upstream side of the conduit and the node at the downstream side of the conduit. So it's very important that your conduits all point in the correct direction. So when you're building your conduits, you can use that same method that we used in our culvert data to identify the flow direction, where we change this from a simple line to an arrow. And then you can see that your flow direction goes from the upstream to the downstream. And when we do that in this section of Flow2D, you can see that you got that correct, like right here. Now, if you mess one up, one of the things you can do is you can reverse a conduit direction. So if I toggle Edit, I have this toolbar here that is called an Advanced Digitizing Toolbar. So you may not see that. So if you want to get that, you right-click anywhere in the toolbar area, and then down here under the toolbars, just check on Advanced Digitizing Toolbar. I'll check it on, and then I'll check it off, and then I'll check it back on. And then if you want to use, if your conduit is set up in the wrong direction, you can reverse the line. So you can go, this is reverse line. So what you do is you click on that, and then you click on the conduit that you want to reverse. So if I click on that, then it reverses geometry. So you can see it's now pointed in the opposite direction. So obviously that's wrong, so I'll click it again, and that will reverse the direction again. So it's just a quick way to fix those without having to redigitize the whole line. I'm going to not save those changes and turn the editor off and discard those changes because I want to stick with my original conduit. And again, we're done with that, so I'm going to turn that off. I just wanted to explain what this was doing. This is just auto assigning the conduit inlet and outlet nodes. Now, we have a lot of type 4, meaning that we have a lot of head walls in our system. So we set up type 4s with a rating table or a generalized culvert equation. In our case, we have all rating tables. So I'm going to open this, and I am going to, hang on a second, let me go up, Coastal 2D Training, Project Data, Storm Drain, and then we have all of our rating tables right here. So anything that has like a .txt or a .dat is the rating table for your culvert, or I'm sorry, for your inlet of your head wall. And I will just select all of those and click Open. And what this says is that 0 culvert equations were imported and 59 rating tables were imported. And you can see details in this file if you had any errors. Click OK, and then I'll show you that file location. So this is project data, type 4, and then in here is this, let's close these guys real quick. Okay, and in here tells you which ones were imported, and if it didn't find one, it would tell you that it was missing. Okay, I'll go ahead and close that. And also, just to show you what these look like, they are very simple. They're just a rating table that is tab or space delimited. Tab, space, comma might not matter. Just delimited data. And it's just depth on the left and discharge on the right. Okay, and I will minimize that. We no longer need that because we're finished with that. And you can see if you select one of those, you'll be able to see and edit the rating table here. Okay, now let's go to the next step, which I believe is to schematize the storm drain system. So at this point, most of our data is basically still in our user layer data. So once we hit the schematize button, what it's going to do is it's going to convert some of our data to the Flow2D layers, which are these guys. Wait, nope, these guys right here. So it's basically just filling out these groups so that when we export the project, it's going to export this into the storm drain groups. Now, one thing that has kind of changed, oh yeah, so you see here's your outfalls and here's your inlets, and then there's junctions in there too. Let me see. Yeah, you got your inlets, outlets, junctions, but of course the swimflow.dat doesn't use inlets, so, or I'm sorry, doesn't use junctions. Swimflow.dat only applies inlets, so when we export that data, you'll get to see what it looks like. Okay, let us do that now. Let's export the project because I think we're finished with this storm drain. So let's see. We want to make sure that our culvert switch is on, our channel switch is on, our storm drain, rainfall, infiltration, all those switches are on, right? So let's check that real quick. And we can see here that we have a 24-hour simulation, 0.1 output interval. We are not running the graphics display, so we don't need an update interval. We are running the text display. And main channel, yes. And rainfall, infiltration, and storm drain, yes. And hydraulic structures, yes. Those are all on. So we can cancel this because we didn't make any changes, and export and get ready to run. So we export that to, let's see, project export folder, storm drain test. We select the folder, and this is what it's going to export for us. I'm going to go delete everything in that folder real quick so that we don't have any hidden data in there. So this is storm drain, Control A, delete all that, and now we can fill that up. Okay, so we click OK, and we click, and yes, we did schematize it, and yes, we do want to export the storm drain files. So this is a new system you haven't seen yet. So we click yes, and that's going to export it. But now be careful, because look, when it goes to select your export folder for the IMP, it actually sets it to the wrong folder. So be careful about that. You need to go back to the project export, select the storm drain test, and then this guy shows up, and it's got some tooltips that you need to pay attention to. So your start date, you're going to want to correlate or synchronize with like tide data or storm data or something like that. If you have any of that data in your INP, we don't. So what we're going to use is the default, which is just picking the date from the computer. And your end date, which is here, is going to be like, in this case, plus 24 hours. So this needs to be synchronized to the simulation time. Now that's very important, okay? And what else here? Oh, and then all the rest of this is just your preference, or, specific to your project. You don't get to choose the flow units. It is going to use cubic feet per second because this is a this project is in state plane coordinate, or NAD 80. Let's see, it's NAD 83 coordinate system, US feet. So we're using feet and not meters, so it's going to be cubic feet per second. Done. That's the only one you can do, either cubic feet per second or cubic meters per second. And then this is going to be chosen by Flow2D, and a lot of these others are also going to be chosen by Flow2D. So we click, and defaulted by Flow2D. So we click OK, and this tells us that this is what was saved to the IMP file. Click OK again, and this tells us that this is what was exported into our run file, and as you can see, these are the storm drain files. Click OK one more time, and now if you go into your project folder, you can see that the new storm drain files were exported. So if I open those in Notepad++, you kind of get to see them. Swim IMPs are here. Swim out F, see all our outfalls have a switch equal to 1, that means that we set those to share back to the Flow2D grid. If they had a 0, that would mean they would be acting like a sink, like as if the water were going off the boundary of the Flow2D grid. These are the rating tables that were imported from those text files, and this is the swimflow.dat. So you need one of these for every inlet that connects to the surface and communicates with Flow2D at runtime. All right, let me go ahead and close these. And I want to show you one final thing about this. If you want to test your IMP to see that it's correct, you can open the EPA Swim 5.0 and you can drag and drop that IMP file right onto there and it will load it, and then you can start checking the lines. So for example, if I wanted to check a line, I could click this guy right here and I could go to the start of the line and the end of the line and find the path and click OK, and you can see the conduit, or excuse me, the line. And this one is actually out in the river channel, so it might have a tidal influence on this one. I don't have a tidal influence set up on this one, but it's definitely something that you could do in a more advanced lesson. So we're going to close this, and I do indeed check all of those lines before I run the model just to make sure that they all look correct. So let's go ahead and let's see, we want to start the run, right? So if we click this button, we want to check our run settings. This should of course go to Flow2D Pro folder, and this should go to the storm drain test. The run settings are great, so we click this and run Flow2D, and it's going to start, and then we're just going to leave it running while the next lecture is being given. So just wait for that. What we're looking for is data errors. No data errors. Excellent. So now we minimize that and leave it running, and we now can save our project, and that will save these guys, and we close it. And the final thing is to set up a quick backup file for that. So I am going to select those and compress to zip, or of course I prefer to use 7-zip, even though in Windows 11 it's not as user-friendly as it used to be. Okay, and then of course we will call this storm drain complete and pop that into our backup folder. And now we can continue on to the mitigation lesson, I believe. No, urban features. Nope. Okay, continue on to urban features. So I will go ahead and close the video down for that.